Hi there, folks. Let's take a look at some advanced parallel circuits as opposed to series circuits that were shown in our last video. Now, this is a parallel circuit that we have in front of us. That's because there are two separate branches on which the lamps are. If I close my switch, I can watch the current flowing throughout the entire circuit, including through both of those branches. Now, we're asked to find a couple of things. First off, what is the voltage across each of the lamps? Then what is the current through each of the lamps? And lastly, what is the current at the switch over here? So let's start by doing that. To find the voltage in a parallel circuit, even if it's one of these advanced parallel circuits where the resistances of the two bulbs are not equal, it's still relatively easy to do. And that's because if we use the same parallel circuit logic that we did from the first week, it still applies. Each of these lamps are on their own individual path with the full battery. That means the 5 ohm lamp is going to get the full 10 volts from the battery. And the 20 ohm lamp is also going to get the full 10 volts from the battery. It's almost like they're connected up independently of each other. And so we can confirm that by using the voltmeter. If I hook it up to either side of lamp 1, the 5 ohm lamp, notice it's 10 volts. If I were to do the same thing for my second lamp, lamp 2, I should also get 10 volts, and indeed I do. So it's like each of these lamps are individually hooked up to the battery. So let me disconnect my voltmeter again. And now we're going to see if we can find some information about the current. And the current is the trickier part of the parallel circuits. However, it's mostly still the same idea using Ohm's law, or V equals I times R, where we're solving for I, the current. So, according to Ohm's law, voltage divided by resistance, that's going to equal the current in amps. An ammeter is going to help us find the current. And so, let me hover my ammeter over lamp 1. I'll notice it has a current of 2 amps. Now, how did I get that? Well, if I go back to my voltmeter across lamp 1, you'll notice that it was 10 volts. 10 volts divided by 5 ohms, that would indeed be a current of 2 amps. However, keep in mind that this is a parallel circuit. Unlike a series circuit, current does not need to be the same everywhere. If we look closely at the flowing electrons, you'll notice that the electrons actually go faster through the top branch than they do through the middle one. That makes sense. They each had the same voltage or the same push, but the top branch had less resistance. So the current is going to be able to go faster there because there's less resistance holding it back. So let me take my voltmeter and I'm going to apply the probes across lamp 2. And I'll notice that lamp 2 has a voltage of 10 volts as well, just as we saw earlier. But now if I use my ammeter, I'm only getting half an amp, 0.5 amps. That's because 10 volts divided by 20 ohms, that's only 0.5 amps. And so my current is lower through the middle branch. That's fine because the two branches are separate. This branch had more resistance and a lower current as a result, since voltage was the same. Now, the last part is perhaps the trickiest here, and I'm going to actually put my voltmeter completely away to do that, and that is to find the current at the switch. You'll notice that at this junction over here, the current from the top branch and the current from the middle branch combined, and now the current's moving even faster down here. We had, if I use my ammeter again, 2 amps in the top branch, half an amp in the middle branch, so that means when they combine, it should be 2 plus 0.5, and that should get me 2.5 amps at the switch. The current has combined at that junction, it's come together, and now it's 2.5 amps going back to the battery. Hopefully that helped you see a little bit about how parallel circuits work. Remember that in a parallel circuit, each branch still gets the full voltage from the battery, but the current in each branch is going to be different. This is unlike series circuits where the voltage was split between the lamps and the current was the same. So keep those differences in mind. We'll continue to work on those for a bit, but hopefully this helps you see a little bit more about how parallel circuits work, especially when the resistances of the two lamps are not necessarily the same.